the triangle XYZ in figure 1 has XY. All of this is equal to 6. ZX is equal to 4. And the angle ZXY is equal to alpha. We're told that the point W lies on the line XY. The circular arc ZW is a major arc of the circle with radius, centre X and radius 4. Show that to 3 significant figures, alpha is 2.22 radians. So let me just draw this triangle out slightly separately to hopefully make this a little bit clearer. Here's alpha, I know that this is 4, I know that this is 6, and I know this is 9. So I can use the cosine rule here. I can say that cos alpha is equal to 4 squared plus 6 squared minus 9 squared. It's crucial that the 9 is the one that you're subtracting because that's the one that's opposite the alpha. Doesn't matter about the other terms. The 4 and the 6. Divide by 2bc. I'll then do cos inverse of that. So cos inverse of that fraction, making sure that your calculator is in radians. So cos inverse of 4 squared plus 6 squared minus 9 squared, all divided by 2 times 4 times 6. And we get 2.2195, which to 3 significant figures is 2.22 radians. Part B. Find the area in centimetres squared of the major sector XZWX. XZWX. So what's the area of this? Well, I know that the area of a sector, as long as I'm in radians, can be found by doing half r squared theta. In this case, I know that the radius of this sector is 4. Right, the angle is going to be whatever this angle is. Well, in part A of the question, I worked out that alpha here was 2.22. And I know that the angles around a point, will add up to be 2 pi radians. Let me just clear this up. So just remember, in degrees, the angles around a point are 360, but in radians, that is 2 pi. So if I do 2 pi, take away the 2.22, that's going to give me the angle that I need. So 2 pi, take away 2.22. I find that the angle I need there is 4.063, and so on. So let's use that in our area formula. So we've got a half times 4 squared times the angle, and I find that the area of that major sector is 32.5 centimetres squared to 3 significant figures. The region enclosed by the major arc ZW of the circle and the lines, hang on, let me mark this onto the shape to make it super clear. So the region enclosed by the major arc ZW of the circle and the lines WY and YZ is shown shaded in figure 1. Calculate the area. Okay, well that's the area of the whole shape. So that's the area of the sector that I've just worked out plus the area of the triangle. The area of the triangle I can work out using the formula area equals a half AB sine C. where C is the angle in between the two sides, A and B. So a half times A will be 4, B will be 6, and C is the angle in between them, which we worked out in the first part of the question was 2.22. So type that into your calculator. We get 9.56 to three significant figures. That's the triangle. So we are now going to have to add that to the sector. So 32.5 plus 9.56. And we get 42.1 centimetres squared. So that is my answer to part C. Finally, part D, the perimeter of that shaded region. So let's go through this and see what we know already and what we still need to work out. So perimeter, all the way around the outside. Well, I know that's 9. Right, this length here. Let me use a different colour actually to make that a bit clearer. This length here. Well, I knew that the whole thing was 6. And I know that this is 4 because it's the radius of the circle. Therefore, that's going to be 2. 6 take away 4. Now I just need to work out what's this length around the outside, what's the arc length. Well, remember that the arc length is just r times theta, where I know that r is 4, and I know the angle here is the 4.063. So timesing those together, I find that the arc length is 16.25. Add that to the 11 to get the total perimeter, which will be 27.3 centimetres. And there we go.